7.4, adding and subtracting rational expressions with unlike. So this time we have unlike denominators. So that's going to change things. These are the steps that they have in the book. On the book, they want you to find the LCD, which I'm going to skip because I noticed throughout the years that students do better when they do the butterfly method instead of finding the LCD. And then everything else is just after you do the butterfly. We don't really have to do this. This is already like something that you guys do anyways. When you change that and then you make it equal to whatever you get after you do this. That's what they're saying. Like you start with something and then equals. After you've done the butterfly, whatever you get from that butterfly, you put it equal. So rewrite rational expressions and equivalent expressions. Then this is what we are going to do. We're going to add, subtract numerators, and then at the end we're going to simplify like we've been doing with this section, the other sections. So let me do this one. So this is example 1. So they want you to subtract these ones. So for each, I'm going to do the butterfly method. So a times a, this times that, minus 4 times that, 4 times 2a, over 4 times 8. So equation, that's what they mean, equivalent 8a, so this is equivalent to that, and that's equivalent to this. Minus 4 times 2, 8a, over 4 times 8 is 32. And then, so equals, so let me put it here, equals 8a minus 8a would give you 0 over 32, so 0 divided by any number would just be 0. That's it. So now let's do this one. And of course the book starts with the monomials. Monomials are always the easiest ones to simplify, work with. So 3 times 25x, we're adding this expression of rational numbers. 3 times 25x plus 10x squared times 7 over 10x squared times 25x. So 3 times 25, where is this? Oh. So 3 times 25 would be 75x plus 7 times 10 is 70x squared over 10 times 25 is 250. And then x times x squared is x cubed. Right. And then we're gonna have to switch this thing around because I don't like it like that. So this is equivalent. So I'm gonna put this one first. Plus 75x over 250x cubed. So we need to, this is where we have to simplify. So find a GCF, so x and x. And the number, let me see if they can GCF a number. And that would be, I think we can GCF a 5 for sure. Let me do a 5. So let me put it here. So 5x GCF, which we've been doing, 250x cubed. So 70 divided by 5 would be 14. I think it's 14, and then x squared over x would just be 14x, and then 75 divided by 5 would be 15, and then the x's cancel. So plus 15. So now we have it here. Now we can simplify this part. So 5 over 250. You can put it in the calculator. So this part of 5 and the 250 becomes 1 on top and 50 on the bottom. Let me put it here as a notes, maybe notes. So this is what happens with 5 over 250. Both numbers can be divided by 5. So 5 over 5 would equal 1. 250 over 5 would equal 50. That's why I have 1 over 50 for these two numbers. And then the x, so x and then x cubed. So basically you take 1 away from this, it becomes a 2, and that one goes away. So you have the x squared at the bottom. And then you still have this stuff here. 14x plus 15 on the top. So I'm going to rewrite this as 14x plus 15 because we don't need the 1 over 50x squared. On the book they switched these two numbers for the two terms for some reason, but this is the right answer. Okay, it's because over here that's how they started, so they kept the x, this x on these sides. But I like to have it this way. So that's the answer. Now this one's it's the same thing. The only difference when you guys do this one's there's going to be cases where you want to combine these two when you multiply them, and there's cases that you might not want to do that. But let's do the modify. So again, this times that, and then that times that. So 6x times x plus 2 minus 3 times x squared minus 4 over x squared minus 4 times that one, x plus 2. So let me see what works better. So let's simplify the top, all of the top first. I think that's what they're doing. Let's see. Yes. And actually I just saw something, guys. This one you can actually factor out, so we're not going to do anything with this except factor this. Is what I mean. So this part would become 3. You can say this question is a little bit more complicated than what we're doing, than what we have been doing. So this part would be the a squared minus b squared. This book loves this difference of perfect squares. So this that would be this. So this is already in x squared form. So 4 you can make it look like this. 2 to the square would be that. So now it's in the same form. So we can find the answer as x plus 2 and x minus 2. So that's x plus 2, x minus 2, and then we have the x plus 2 here. So the bottom we're done. So this is a note on how to solve that. And then the top we're gonna have to combine everything, and I just noticed again this is the same as this. So let's do that first. So 6x x plus 2 minus 3, and then I'm gonna put parentheses. I'm gonna factor that one first before we can do anything. And that would be, if that one's the same as this, so that would be this x plus 2 and x minus 2. Okay, if now we need to see if we can GCF something from the top. And this is a little bit different because now it's not one letter that you can see that you can simplify it easy. Now the numbers, the 3 and the 6, we know you can GCF a 3 from both sides. And let me show you something. You can actually GCF this whole part, this one and this one, because they're the same thing. Imagine this being an x, you could GCF an x. In this case, we have an x plus 2, but it's still x plus 2 and x plus 2 is still the same thing twice. So you can GCF an x plus 2 and x plus 2. So this is where it gets a little bit more complicated, because you need to think about factoring first before you sometimes can combine the whole thing on the top. So now we're gonna GCF the 3 x plus 2. So that's the GCF. The bottom stays the same. Okay. So from this term, 6 divided by 3 becomes a 2. And then you still have that x, because we couldn't take out an x, so we still have that 2x, that x, and then this part goes away, so you just have 2x here, minus, so 3 over 3 goes away, x2 over x2 goes away, so you're left with this part, x minus 2, like that. Put another parenthesis. So maybe we can combine this part now. So let me rewrite it, x plus 2 times x plus 2, x minus 2, x plus 2. So 2x minus, so this is going to become 2x, and then you distribute minus x plus 2. So as you can see, it gets a little bit more involved than what we did last time. So this would be 3x plus 2 times this 2x minus x becomes x plus 2 again, and then so that's why you're left inside this parenthesis, and at the bottom we have x plus 2, x minus 2, and x plus 2. So now we cancel, we simplify it, so we can actually get rid of this with this and this with that. So we're gonna simplify these two, those two, and we're left with 3 over that. So, ooh, where are they gonna fit here? So the answer would be 3 over x minus 2. Oh, sorry, that was ugly. X minus 2. Let me see if that's what they got. Yes. So that's what they got in the book. So that's the answer, guys. Let me highlight it. This one, great one. So that's the answer. Okay. So let's move on. Yeah. So let's do this one. Now we're adding. So let's do this one. Looks a little bit simpler than the other one. But let's see. So it says here add. That's all we're doing. So let's do the butterfly. So 2 times, put it in parentheses, plus 3t times 5 over 3t times t plus 1 equals, so let me see what we can do here. I think for this one we're gonna have to simplify the top, all of this stuff. Let's see if that's gonna work. Yes. So let's simplify the top, because I don't see anything that we can factor out from here. So we're gonna distribute this into this. So So 2t, right? 2 times t, and then 2 times 1 plus 2, right? And then plus this one. 3 times 5 would be 15, and then the t. And then we still have this at the bottom. Do not combine this one yet. Let's see. Let's do the top first, and then we can think about this. So this one, 2t and 15t becomes 17t, and then you have the 2. This is a plus sign. That's not a t. This is the t, and that's the t. So you have plus 2 here. And then over, so this is a t, and then we have 3t, t plus 1. And we can't do anything with this one. So that would be the answer, because we can't GCF anything from here, not the numbers, not the letters. So that would stay like this. There's nothing else we can do. That one was easier. Now let's do this one, subtract. So we're gonna do the same thing, and like this. So 7 times 3 minus x minus x minus 3 times 9 over x minus 3 and 3 minus x. Okay, so this is one of those tricky ones, because if you notice, these ones are switch, and you can actually GCF a negative from one of these and also this one, just to make it look like it usually does, which is this. So I'm going to GCF a negative 1 from here and from here. This is what I mean, because they're switched. When you see that and it doesn't feel normal, like this is not the usual, then GCF a negative, that would help. So this one, we have a negative 1 outside, so it would be a negative 7, right? Negative 1 times 7 would just give us a negative 7. So inside, negative 3 divided by 1 would become a negative 3. Negative 3, and then negative over negative would become positive x. And then the rest will stay the same. Times 9. Then from the bottom, the first one stays the same, this one. And let's take out the negative. So this negative 1, I'm going to put it in front, negative 1. If you want to put the 1, that's fine. And then this would become negative 3, negative over negative, positive x. So now let's clean it up. So this is negative 7. I'm going to switch this one's x minus 3 now. So I'm using those commutative and associative properties. And switching things around is still the same thing. And then x minus 3, and then I'm going to put the 9 in front. Just that, because that's how things usually look, and I like that. And then I'm going to clean the bottom part, so I'm going to just put a negative. I'm going to take rid of that 1, we don't need it, and then x minus 3. And then I'm going to switch again, so x minus 3. So now it's clean. Now I'm going to GCF. So let me put here GCF. So what can you GCF from? This is already factored out, don't mess with it. We can actually GCF something from this one. And I would GCF a negative. If you notice, these two things are the same, so let me highlight them. This is why I want you guys to start seeing that. This is subtraction, that's a negative. That's a subtraction. Imagine this would be the x, like it was, like usually we got an x here. Now it's an x minus 3, but think of it as an x. You can still GCF these two things. So we're going to do x minus 3 parentheses, and I'm going to take out the negative again, and then x minus 3 parentheses and the negative. So that's the GCF, this one. I'm going to put it here so that you see it. Negative x minus 3. So this is the GCF. And then we have all of these in parentheses. So negative over a negative becomes a positive, and then the 7 stays. The x minus 3 simplifies, it cancels for this part. So that's where we're left only with the 7. Negatives became positives, 7 stayed, and the x minus 3 cancel. Then you have minus, actually no, because I remember I did a negative here. So negative over a negative will become a positive. The 9 stays, and then the x minus 3, what happens? Ooh, I should have done that before, but I did it like this. I should have combined these two. They were like terms. I just noticed that. Because if you notice, we have numbers, so we could have combined these two from the beginning. That would have made things easier. So now we have that. Over negative x minus 3, x minus 3. Now let's simplify. So we'll have to copy it again. 7 plus 9 is just 16. So now I'm gonna put the 16 in front over negative x minus 3 and x minus 3. So this is what I was saying. This part I could have simplified that from here. Instead of doing the GCF, I could have just combined this and have this from, and we wouldn't have to do this stuff. But I mean, I did it like this. So the negative over a negative becomes a positive, and then you have the 16 x3 over x3. So one of these cancels, and you're left with x3 at the bottom. And that should be the answer. I don't think we can do anything with that. Yeah, and that's the answer. Okay. So again, you could go from here if you recognize it. I didn't recognize it at first. These two are like terms. So you could have combined negative 7 minus 9 would have given you negative 16. And then the x minus 3. Instead of doing that, but extra steps. Got the answer. So this one. So add. So we're going to have a 1 here. When you see that, you just put a 1. I'm going to keep doing the butterfly because it just makes things a little bit easier. Like that. So 1 times that will just give you that. Plus 1 times that just gives you that. Right? We have a 1 and a 1. I just got rid of the 1s because we don't need them. And then 1 times that just give you that. So be careful here. You don't really cancel these two because there's a plus sign here. So don't fall into that mistake. You need to simplify the parts, the numerator. So this would be m plus 1 plus m over m plus 1. So m and m are like terms, so 2m plus 1 over n plus 1. And that would be the answer, guys. There's nothing we can simplify here. We can't GCF anything from this one to make it look like this one. So 6, question 6. So this one gets a little bit more complicated, and I'm gonna skip 7. I think I'm gonna stop at 6. So again, let's do this, and that. So 3 times 6x plus 3 minus all of that stuff turns out. So 2x squared plus x, I'm going to put it in parentheses, this part times that, 2x over 2x squared plus x times 6x plus 3. Okay, so now what can we do? I think I'm going to simplify maybe GCF this one, so we can GCF things from here. We can GCF a 3 from this one. We can GCF an x from this one. So let's do this one. So this one would be the x is outside, and then for this one we have the 3 outside. So 2 over, there's nothing, so you're left with the 2, and then x squared over x becomes an x. And then x over x becomes a positive 1. And then this one, we have the 3 outside, GCF, and then 6 over 3 is just 2, and then the x. And then 3 over 3 is just plus 1. They look the same. They're actually the same. So now let's do the top part. Let me think about this first. We can GCF the same thing here and here. Okay, so we can GCF 3 from this one. So this is gonna be like the last one that I had an extra step. This one I'm gonna make sure I don't have that extra step. We can GCF an x from this one. So we have a 3, and this 3 is already on the outside. So we can have a 3 times that GCF 3, and then in the inside, and I'm gonna leave it like that. I'll simplify later. 6 over 3 would be 2, and then the x. 3 over 3 would be plus 1, and that's where this minus. Now the 2x, I'm gonna put it in front. 2x times the GCF, which is x, and then I'm gonna simplify the parentheses. So 2 stays, there's nothing here, and then x squared over x is just x, and then x over x is just plus 1. So let's simplify again. So 3 times 3 would be 9, 2x plus 1 minus 2x times x, that would be 2x squared over 2x plus 1. Okay, and then this one over x, I'm gonna combine this two, 3x, so 3 times x, and then 2x plus 1. You could combine these two, but I'm just gonna leave it like that. That's equals. So I was gonna add, but this ones we can't. So I'm a GCF. Actually, this one we're gonna have to GCF 2x plus 1. You notice they both have the same one. 2x plus 1. I thought we could combine it like that one, but we can't. So we would have 2x plus 1. That would be the GCF. So GCF here. And then we're going to have the inside. So 2x over 2x plus 1 cancels, so you're left with the 9. And then this one cancels, so you're left with the 2x squared in the inside. And then we still have this part, 3x, 2x plus 1, 2x plus 1. And we can actually get rid of one of these, like that. Let me see, and we're left with this top part, 9 minus 2x squared over this part, 3x, 2x plus 1. Yes, that's the answer. This is like, I think this, and maybe there's one more section that the algebra might get even more difficult than this one. but that's gonna be like the top. When it comes to difficulty, I don't think it's gonna get more than difficult than this, because as you might think, there's even more complicated algebra that we don't see in this class. Luckily, that would be crazy. So that's it, guys. Thank you.